Hi, everyone. My name is Dayann. I'm an undergrad at Johns Hopkins University. I'm going to talk about LLVM-CM, which is a static cost modeling tool that I worked on this summer alongside Mircea Trofan. So a little bit of background. The MLGo project, it's essentially like machine learning guided compiler optimization, trying to integrate some ML techniques into LLVM for compiler optimizations to like replace the existing heuristics. There needed to be like a kind of a ground truth way to evaluate the performance of those ML guided optimizations. So the entire goal of LLVM-CM is to kind of just give a training signal. Or like a way to get that ground truth like performance number at the end to like say how good a specific performance optimization was. So a little bit of background regarding the beginning. There's this thing called Weka. It's a machine basic block throughput predictor, really similar to LLVM-CM, Yaka, or ITHEMO. I'm going to talk more about ITHEMO later. It shows results within 1%, I think, of Beehive benchmarks. So like just very, very accurate. And it essentially just disassembles code, gets operands and opcodes, and then matches that up to just a crazy amount of information on like the uops.info site. So just like performance data. Didn't really work. The amount of like manpower it takes to maintain the information that's held on uops is insane, and there are some other issues. So yeah, then we talk about ITHEMO, moving closer to kind of what CM tends to fall in. It's another throughput predictor, uses LSTM. The entire point of using a machine learning model is that just Weka created the performance model by hand. Very error prone, very lengthy process, kind of just a lot to do. So just having something that can be that can kind of not have that much manpower be invested into it, and getting like estimation at steady state is just very helpful. So yeah, ITHEMO uses information about the instruction architecture and training data and just generates predictions. And then moving further, then we have Granite, which is another kind of like ML-inspired throughput predictor. It uses it estimates throughput of basic blocks on a variety of different microarchitectures. A lot of the same reasons for existing that ITHEMO does. The unique thing about it is that it uses a graph neural network to kind of like map some dependencies between basic blocks. Yeah, and it does a lot of it helps with a lot of the aspect that you need a lot of like domain expertise and just time in order to like have like a very like for example what uops does, where you have like a very very representative amount of data. So yeah, now moving into CM. Essentially what CM does is that it disassembles assembly code, then it ingests a ML model such as Granite, and it just performs latency estimation at the basic block level. So it'll map instructions to machine basic block addresses. It'll get some profile data, I think, basic block frequency data, or instruction frequency data. And then, yeah, it just aggregates and produces a value that can be used as a performance metric. And then, in theory, it could be used for any microarchitecture because it just depends on what model it ingests. So it kind of serves a role as like a harness. You could feed it anything. You could feed it something, and then it would give you whatever it will give you a number based off whatever that thing is designed for. It exists right now on GitHub. Like there's a Gematria repo that people can look at it on. And I mean, yeah, that's pretty much it. I had a slide for questions, but we don't have time for that. So, yeah.